Hello everyone, I am Shukadra Puja, Assistant Professor, Department of Computer Science and Engineering, BLDS, PP Dr. PG Harpati College of Engineering and Technology, Jaipur. In last class, we have discussed about hash functions. So, and that too, why we require hash functions, motivation for hash functions. So, and after that, how we need to use hash functions in our cryptographic functions. So that is what in the introduction part of hash functions we have discussed in the last class. So now in today's class we'll discuss um, a modified version of hash functions. That is what we can call it as a crypto hash function. So what is actually the crypto hash function? So in that previous class only we need to send the data by applying a hash over that data and send it to the receiver. So there are some weaknesses in that, there are some disadvantages in that hash functions. To modify, to improve that, we'll be applying uh, encryption procedure on the hash function. So that is what we can call it as crypto hash function. So in this crypto hash functions, what actually we require is, anyhow already as per my last discussion, what the h of x is a hash on x. So hash data on x, that is something nothing but h of x must provide what actually provide compression. So compression is nothing but whatever we are going to get the output, that length should be small. So you know already something about compression efficiency. So h of x, how efficient this particular hash function is, that is crypto hash function is. So talking in terms of efficiency, here in this h of x easy to compute for any x. So if a given value of x, so whatever the data which relates to x, then we can compute easily hash on that particular value, that is hash of x or h of x. And as per my last discussion, that hash function is always one way. One way in the sense, say for example, given a value y, it is infeasible to find an x, such that h of x equal to y. If so, if h of x is equal to y, then with those two values h of x and y, it is highly infeasible. That is a reverse operation, highly infeasible to find out the value of x. That is what we can call hash function as a one way. Then weak collision resistance. So now there are two more possibilities occurs in this hash function. Say for example, given x and h of x, assume that x and h of x is given, infeasible to find y which is not equal to x. One in this case is infeasible to find y which is not equal to x, such that h of y is equal to h of x. In this case also it is highly infeasible to find out the value of y is not equal to x. Now one more point is strong collision resistance. So weak collision resistance in the sense we are computing the other value, that is y. Strong collision resistance is infeasible to find. So on which we have applied the hash function, the same value we need to find out. Even in that case also it is infeasible. Infeasible to find any x and y both here with x is not equal to y, such that h of x equal to h of y. This is what some of the crypto hash functions what it provides. Compression, the output length should be small, efficiency h of x is to compute for any x, and it is one way. Weak collision resistance, strong collision resistance. Now here what we discussed in the last class, there is a lot of collisions exist but hard to find any. Now based on this, so before going to discuss in detail about that crypto hash function, we have certain applications, certain examples here, very interesting example. That is one problem, we can call that as a problem actually. So pre-birthday problem, what actually this pre-birthday problem is. Say for example, assume that consider the classroom itself. In a classroom there are n students, n people or n students in a room. Now what actually we need to find out is, we need to find out I mean, we need to get the probability of the students or else people who is having the same birthday as that of me, that my birthday. That is what, how large. So we need to find out in terms of n here. N in the sense total number of students in a classroom or else total number of people in a room. How large must n be before the probability someone has same birthday as me, which is actually, if a standard as one given by that, which is actually greater or equal to 1 by 2. That's a, which is more than or equal to half of the probability. That in that way we need to calculate the value of n. How large must n be before probability someone has same birthday as me. So in the sense, you may be confusing a little bit about this. Say for example, as we need to go on increasing the value of n. Say for example, if only 10 students are there, okay, only 10 students are sufficient to get the probability that among 10 students, more than half. I mean, to find out only one student birthday which is same as that of me. If it is not satisfied, then we have to increase 11, 12, 13, 14. So that's what the question is. How large must n be before the probability someone has same birthday as me, which is actually more than half of the value, that is 1 by 2. So now here in this case, to find out n, we need to solve uh, the value for n here. So we need to apply the equation 1 by 2 equal to, so we need to subtract among 1 here, 1 minus 364 divided by 365 raised to n for n. So here, why it is considered as 365? 365 in the sense, in a year there will be 365 days. So except me, we have to subtract that is 1 minus 365 by 365, 364 by 365 raised to n. That is all the probability. So we need to solve this equation. We can get the value of n as something else. We find n equal to 253. Assume that in a room, if the total number of people are 253, then we can say the probability that uh, someone has the same birthday as me. That is what the probability is, more than 1 by 2 with the value of n equal to 253. This is what the pre-birthday problem. So that's continued here. How many people must be in a room before probability greater or equal to 1 by 2 that any two or more have same birthday? Now the equation is, so in that previous slide